Okay, so here, this is the review for test. This is basically what we did in class. So I'm gonna go over really fast on what we need to do. So here they said factoring each. So when they say factor, you just need to put a parenthesis, okay? Those are the factors of this quadratic expression, right? So what you need to do is when this is, when n, well, in this case, remember, this is written in this form, right? Ax squared plus bx plus c equals 0. But since this is not equation, this is written in this form. So the only thing you need to do is, remember, when a equals to 1, which is this case, because there's no leading coefficient here, the leading coefficient here is 1, this problem is simple, right? So you put a parenthesis here, you do n, right? The sign is positive, so that means that both signs inside the parentheses are going to be positive. How do you know that? This sign tells you the signs are going to be the same inside the parentheses, right? And when you have this positive, that means both are going to be positive. So you think about what two numbers when you multiply give you 42, and when you multiply give you 42, and when you combine give you 13. So that must be 7 and 6, right? Because 7 times 6 is 42, and to get the middle term, which is this one, right? You just need to combine like terms. So this is going to be 7n, and this is going to be 6n. So if you add them, you get 13n, right? So that's the middle term. So that's how you know if the factoring is correct or not. And to get n squared, you get n and n. So remember, n times n is n to the second power. So that's how you know that this is the correct factoring, right? When a equals 1, it's very simple to do the problem. Okay, so that's the answer, right, for the first problem. M plus 7, x, m plus 6, right? Simple. The second one, I have to do, now this time it's just r, right? So you do the parentheses. Again, look, the leading coefficient is 1, right? So it's easy. So you do r and r. Again, the sign is positive. That means that the signs are going to be the same. And then you look at this sign. So since this is negative, both are going to be negative, right? So you think about two numbers, when you multiply, they give you positive 70, I'm sorry, positive 70, which is this number right here. And when you combine, give you negative 17. So you have to do 7 and 10, right? 7 and 10 will work. And you might say, oh, but in the answer key, they have it backwards. Doesn't matter, right? Because a times b is the same as b times a, right? Multiplication is commutative. So if you write it this way, it's the same as the one that you have above, right? This is the same as this. So don't get confused with which one I should write first. Doesn't matter. That's the answer anyway, right? Okay, so make sure that you understand that. Next, I have n squared minus 16n plus 60. So you do again the parentheses. Why? Because the leading coefficient is what? 1. So this is going to be n. The signs are going to be the same because of this sign, right? And then you put negative and negative. Well, that must be two numbers that when you multiply give you positive 60, and when you combine give you negative 16. That must be what? 6 and 10, right? Yes? And that's it. That's the only thing you have to do, right? If you want to check, just remember, negative 6 times negative 10, negative 6 times negative 10 is positive 60. Then you do these two. This is going to be negative 6n, negative 10n. So this is negative 16n. That's the middle term. And n times n is n squared. Okay? That's how you do that. So you know now how to do it. This is when this thing gets complicated, right? When the leading coefficient, it's not 1. Then that's when we have to use the AC method and the other hard things, right? So here, this is going to be n squared plus 9n plus 2. It's called AC method because I need to multiply a times c. So a times c. That's the reason it's called AC method, right? So what I need to do here is I need to multiply that 10 with the 2. So that's going to be 20, right? So now you factor like you usually do, n plus plus. So you need two numbers. When you multiply, give you 20, and when you combine, give you 9. So that must be 5 and 4, right? 5 times positive 4 is 20. 5n, 4n gives you 9n. That's the middle term. And n times n give you n squared. Okay, so that's how you check. So that's it. But you have to remember, before you said that this is the final answer, you have to say, oh, okay, remember when you do the AC method, you multiply by 2 to make it simple, right? You multiply these 2 to make it simple. However, that was not the original expression, algebraic expression. So you need to divide by 10. Okay? So this is going to be n plus 1 over 2, right? And then you have n plus 2 over 5. Now, because they want the factor form, you need to put this on the top. That's the reason they call bottoms up to this method, right? So this is 2n plus 1. And then you need to do the same thing here. You need to put this on the top. So this is going to, or and then with a variable, right? So that's going to be 5n plus 2. And as you can see, it's the same, right? So make sure you practice these ones because those are the difficult ones. Here again, we need to do the easy method here, right? We need to multiply these two, right? So this is going to be r squared plus 11r minus 180. So now you need to do the factoring. So two numbers, when you multiply, they give you negative 180, and when you combine, give you positive 11, right? So you need to find the factors of that. So sometimes they're easy to find, sometimes they're not easy to find. If they're not easy to find, you can do the prime factorization. So you do 90 and 2, right? 45 and 2. Then you do 50, well, this is not divisible by 2. You go by 3. So this is 15 and 3, right? And you continue, right? So then the next is 5 and 3. So now you need to find out which of these numbers, right, give you, when you combine, give you positive 11, and when you multiply, give you negative 180, right? So let's see. We can do, as you can see here, we have 20. 2 times 2 is 4, times 5 is 20. So that's going to be r plus 20. And then we have left over 9, right? So that works because 20 times 9 is 180. And if you combine those numbers, if you do 20 and negative 9 gives you positive 11, right? So that's going to be r minus 9, right? When this sign is negative, the signs in the parentheses are going to be also negative. So you do 20 times negative 9 is negative 180, and then now you can combine like terms, right? But remember, in the beginning, the problem was 6 originally, right? You multiply by 6 to do the AC method, right? So you need to divide now by 6, right? So you divide by 6, you get r plus 10 over 3, and then you have r minus, well, this is 3 halves, right? Now remember, you need to move this denominator to the top. So that's going to be 3r plus 10, and then this is going to be 2r minus 3, and that's the answer. Okay, let's continue. Don't do this one. I told you in class we're not doing this one, right? We're not doing that. Okay, let's continue. Now they want you, read the question. They want you to solve and factor, or solve by factoring. So you need first to factor, and then solve, right? So don't forget to factor and then solve. Okay. Okay. So now here, this is easy, right? Because the leading coefficient is 1. So that's not a problem, right? So we do x and x. The signs are going to be what? The signs are going to be different, right? Because this sign tells me that the signs are going to be different. Signs are different, right? And signs are different means this is positive and this is negative. And you might say, how do I know which one goes positive and negative? Doesn't matter. You can put negative here and positive. Doesn't matter because you don't know it. This is called trial and error method, right? So you're trying to figure out which are the possible combinations that they give you these values, right? So what two numbers, when you multiply, give you negative 40, and when you combine, give you 3. So that must be 8 and 5, right? Right? So this is going to be negative 5 times 8 is 40. This is going to be negative 5x, and this is going to be positive ax, and this is 3x, right? Okay, so now you need to set this equal to 0 because they want you to solve. So you do x minus 5 equals 0, x plus 8 equals to 0, and you solve. You add 5 in both sides. X equals 5, subtract negative a in both sides, x equals negative a, and you're done with this problem. Okay, next. So this is going to be a, the signs are going to be the same because this is positive, both negative, because I have to look at this sign after I look at the first sign, right? After I know that the signs are going to be the same, I look at this, what sign it is. If it was positive, then it will be 2 positive, but since it's negative, both are negative. So you find the combination for 12. What numbers when you multiply give you positive 12, and when you combine give you negative 7, so that must be 4 and 3. So this is equal to 0, a minus 4 equals 0, a minus 3 equals 0, add 4 in both sides, a equals 4, a equals 3, right? If you add 3 in both sides, that's how you do that. Okay, next. Now, this is not in standard form yet. This is not in this form, ax squared plus bx plus c equals 0. I need to manipulate it algebraically. So that what I'm gonna do is I'm gonna subtract negative 7 in both sides. This cancels out, right, on the right side, and I'm gonna get that nice form, 4b squared minus 31b plus 42 equals 0, right? So now you need to do the algebra, right? So this is AC method again, right? I have the 4 and the 42. I need to multiply those two, b squared minus 31b, and this is gonna be 84, that's gonna be 168, right? And this is equal to 0. So now you need to find what two numbers when you multiply give you 168, and when you combine give you negative 31. So you do that, right? So this is gonna be 8 and 4 and 2. You continue, 4, 2, and 2. I'm dividing by 2. This is called prime factorization. What else I need to do? 21 and 2. What else? 7 and 3, right? Because 21 is not divisible by 2, you go by the next number, which is 3. Let's see. We have 8 and 21, or we can have 6 and 28. Well, 6 and 28. That's gonna, well, 6 and 28. That's you need to figure it out what numbers, right? So meanwhile, we can do this. B and B, the signs are gonna be the same again. So these are gonna be both negative. So I need to find a combination, right? Before I continue with this. You can do, let's see. We have 14 and we can have, let's see, 6 and 12. 14 and 12, that's 28, that doesn't work. I need to get 31, right? So let's see, what about if we do 7 and 2? That doesn't work either. So we need to find, that's sometimes that's the tedious part, that you need to find what number work out, right? Maybe you can do, that's 12, and let's see, that seems not, it's not working though. Let's see what another number. If we do 28 and 6, let's see. Just to make sure, let me see, what is my 49. 42 and 4, this is a 168. Yeah, that's 168. I just want to make sure that I multiply it right. So let's see. Let's see. Okay, everything seems right. Okay. 68, that's a and 4. 4 and 2, 21 and 2, 7 and 3. So for some reason, I'm not seeing the number. Okay, you can do 24 here. There you go. You can do 6 and 4, that's 24 and 7, right? So 24 and 7, that gives you the number, right? So sometimes you need to think a little bit about it. So now you need to divide by the original 4 that you multiply. So you're gonna get b minus 6 in this case, because first, before you do the bottoms up, you need to see if this simplifies, right? So in this case, this simplifies, and then this cannot simplify further. So you're gonna move the 4 with a variable, right? So that's gonna be 4b minus 7. Now you have the factor form. Now you need to solve for 0, right? So this is equal to 0. So, and what I need to do is b minus 6 equals to 0, and 4b minus 7 equals to 0. If I add 6 in both sides, I get 6. And then if I add 7 in both sides, I get 4b equals 7. You divide by 4, you get 7 over 4, right? That's the solution for this problem. So this one came out tedious because the number was big. Let's continue. So here I have to do AC method again, right? I have, but before I do AC method, I need to write it in standard form, which is this form, right? So I need to subtract negative a in both sides. So this cancels out. So 5n squared plus 11n plus 6 equals to 0. I need to do the AC method. So I need to multiply these two together. So this is going to be n squared plus 11n plus 30 equals to 0. Now I need to factor. What two numbers when you multiply give you 30 and when you combine give you 11? Well, that's going to be 5 and 6, right? If you don't know how to do that, you can do the prime factorization, 15 and 2, and 5 and 3, right? So 6 times 5 is 30, and 6 and 5 give you positive 11, right? So at this point, remember, because you did AC method, you need to divide by 5. So this is going to be n plus 1, and then you can move this 5 to the top, so that's going to be 5n plus 6 equals to 0. You solve for that. N plus 1 equals 0. 5n plus 6 equals 0. Negative 1, n equals negative 1. And then you need to solve for this one. So this is going to be negative 6. And 5n equals negative 6. 5 divided by 5, you get negative 6/5, right? That's how you do that. Okay? Not too difficult. Okay, let's continue because there's too many problems here. So a lot of them I didn't in class, so I hope you understand. So here, well, like I mentioned in class, this p, remember this is the square root of 2, right? You can just divide p2 over 2, right? So that's gonna be just p, so that p comes out. Now you have to take care of the number, right? So you can think about, well, you do the prime factorization if you don't know what you're doing. So this is going to be 12 and 2, 6 and 2, 3 and 2, right? So you can write this as 2 to the 2 times 3 times 2, right? Because that's what we have. And you may say, oh, why you don't write 2 to the 3, right? Because I want to divide this evenly. So if I put 2 to the 3 here inside the square root, 3 doesn't go into 2 evenly. So that's the reason I break it down into 2 to the 2, 3, and 2, right? So that this number comes out. So that's going to be 2p square root of 6, right? That's how you do that. That's the easier way to do it. I mean, there might be something else easier, but I show you the class different ways to do it, right? Not just this way. But I want to save time, so this is the easier way to do it. Now this, x to the 4, you just divide. Remember, this is the index is 2. So you just think about this variable as 4 divided by 2 is what? X2. Now you have the 18, the number, right? So you do the prime factorization. So 9 times 2, 3 and 3. So that means this is x squared, and then you do 3 squared times 2, right? So that this guy comes out. So this is 3x squared square root of 2, right? And that's it. That's the end of this problem. Here. So the first thing you have to look is if they have common factors. So these, they're similar, right? It's the same as saying negative 3x minus x. You will say this is negative 4x, right? So the same applies here. You have negative 4 root 45, okay? Now you need to simplify the 45. So you have to do the prime factorization. This is not divisible by 2, it's only divisible by 3. So you have the two numbers here. So this is negative 4, 3 squared times 5. So this is negative 4. That 3 comes out, right? Because 2 goes into 2 evenly. So that's going to be 3. And then this is going to be 5. So this is 12 square root of 5. Okay? That's how you do that. This is the final answer. Next. You always have to see if you can combine something so it makes the problem easier. Here I cannot do anything, right? Because this index or these, not index, these square roots are different, right? So what you can do is negative 3 root 6 minus 3. You need to do the 45, right? So then the 45, you have to do the prime factorization. That's going to be divisible by 3. So this is by 3 and 15 times 3, and this is 5 times 3. So these two, you put inside the square root. So this is 3 to the second, 5, right? And then we have 3 square root of 5. I don't do nothing there because the 5 is a prime number, right? You might say, well, it didn't do nothing with the square root of 6, because square root of 6, the number 6 is just, if you do the prime factorization, you're going to get 2 and 3. So 2 and 3 is a prime number, and 2 you cannot, I mean, that's only divisible by 2, right? So here you have negative 3 root 6. Now these 2 comes out, right? Because you 2 divided by 2 is just 1. So that means that this is going to be 3 times 3 root 5 minus 3 root 5. Now you get negative 3 root 6 minus 9 root 5 minus 3 root 5. You combine like terms, this is negative 12 root 5, negative 3 root 6. That's it. That's the answer, right? You cannot go further because these two are different, right? But these two, in the beginning, I combined them because root 5 and root 5 are the same, so I can combine them. Negative 9 and negative 3, that's negative 12 root 5, right? Okay. Oh, I forgot they have another, oh, that was the top answer. Oh, I thought I did wrong. No, this is the answer for that. Okay. Let's continue. Okay. Number 15. Basically, they're all the same, right? I'm gonna do one more of these 15 because 16 and 17, well, 17 and 18, I told you don't do it, right? So we don't need to do that. So I'm just gonna do one more and I'm gonna go straight to 19. So this is what? 2 root 3 and 2 root 3. Notice that these are exactly the same, so I can combine them. So that's gonna be 4 root 3. I cannot do anything with this one, right? Because this is 5 is a prime number, so this is negative 3 root 5, and then 20, right? 20 I need to, well, I need to do the prime factorization, so that's divisible by 2. This is divisible by 2 as well. So this is going to be 2 and 5, or 5 and 2. Let's put 5 and 2 better. So you can see here that we have what? Two 2's, right? So basically this is 2 squared times 5. So this is going to be 2 squared times 5. So this is 4 root 3 minus 3 root 5. Look, you have this, that comes out. It's 2, and this is root 5. So combine like terms, 4 root 3 minus 5 root 5. That's it. That's the answer. Okay? So make sure that you simplify these terms. Okay, next number. Here you can simplify these two together. Well, this is not a difficult problem. You can do a little trick. You can say, well, the square root of 9 is what? 3, right? You know that. What is the square root of 5? 5. So this is the answer, right? That one is easy. Then you don't need to put too much thinking. Now this one, same thing. What is the square root of 4? 2, right? The only thing you need to simplify is the numerator. So you can think about the prime factorization of A is 4 and 2. The prime factorization of 4 is 2 and 2. So this is going to be 3, 2 squared times 2 over 2, right? And then this come out to be, well, this 2 to the second power, it can go evenly, right? Because the exponent, look at the exponent. The exponent here is 2. So, and this index is 2. So if you divide 2 divided by 2, that goes into 1. So that means that this is 3. That 2 is going to come out, and then the 2 is going to stay inside, because this is 2 to the first. 1 doesn't go even into 2, right? So that's the reason you have to leave that inside. And then here you have the 2 in the denominator. So you can cancel this out, and then you get 3 root 2. So that's the review. Okay, I hope this helps. Good luck to more in your test. Don't overthinking. These problems are basically the same, and basically that's gonna be the same structure for tomorrow. Okay, have a nice day. Bye.